Hey, all right. Welcome back, everyone. Here we are with Anton again, who's going to explain everything to us. Titled, Surprisingly, Nearby Star May Have 8 planets, one inhabitable zone. Habitable zone. Look at his t shirt. It is pointless to resist. Um, okay, yeah, so I don't know anything about this. Where is this star? How far away is it? Well, it says nearby. That's relative. All right, let's see what Anton has on this topic.
Person, this is Anton, and today we're going to be talking
Let's turn
about
it up a
new
little.
analysis and new discoveries coming from one of the more exciting systems near us, the star system known as Tau Ceti. And though we talked about this star system a few years ago, it's actually worth talking about it again because new discoveries suggest that it actually has some really interesting planets in it. Specifically, it seems to possess 8 different planets, with at least one of them potentially being in the habitable zone. But let's discuss this in a little bit more detail, starting with the star itself. The lonely star, approximately 12 light years away from us. If you remember the distances to other stars, this means that this is actually one of the closest stars to us. As a matter of fact, this is the second closest G-type star, and G-type stars are the ones we are particularly interested in, simply because this is what you would call
12 light years. Close by space standards, but by our standards, not. Um, think briefly about how we have not placed a human on Mars um, and haven't actually been to the moon that many times. 12 light years is obviously how far um, light would travel if it was going in a certain direction and had the power to travel um, for 12 years. That's how long it would take to reach there. I wonder how far, like, I feel like Pluto's like, isn't it like 40 AUs, astronomical units from our sun? I wonder how that compares to a light year, or to the Oort cloud, to the edge of the Oort cloud of our solar system. You know, to try to put it into context. I'm not really sure. Maybe I can look that up. How much is an AU compared to a light year?
a solar analog. It's a star extremely similar to our Sun, at least in terms of the amount of energy it produces. Here's, for example, how it compares to our own Sun, with the Sun being on the left. So it is a little bit smaller, it's about 78% of the total mass of the Sun. It also seems to produce about half of the luminosity of our Sun, but in terms of the age, it's relatively similar. It's about 5.8 billion years old, although it does seem to only contain about 1/3 of metallicity of our own Sun, which of course implies that it's mostly made out of hydrogen and helium and a lot less of other materials, which of course could also influence the composition of planets in the orbit of this star. And interestingly, the star is also slowly approaching the solar system, so in approximately 43,000 years from now, it's going to be at its closest approach just a little bit over 10 light years away from us. And because of all of these strange similarities to our Sun, like for example the fact that it's a lonely star, it doesn't have any partners like Alpha Centauri does, and also because originally we've discovered planets here a few years ago, this star has always been sort of the primary source of investigation, speculation, and interest when it comes to search for extraterrestrial intelligence and of course potential colonization of any kind of a star system. As a matter of fact, several different projects looking for extraterrestrial intelligence focused on this star in the past, one being this one.
Sorry to interrupt really quick. Looking up that a light year is about 9 quadrillion 500 trillion kilometers. An AU is 149,600,000 kilometers. Again, the AU, the distance of the Earth to the Sun. Well, that's a huge difference. I don't know what that ratio is, but a light year is way bigger than an astronomical unit.
Right here, Project Phoenix, and one being the older project known as Project Ozma. But of course, nothing has been discovered so far, and at the moment, it doesn't seem like anyone is trying to communicate with us or is sending any artificial signals from the star system. But because the star is so stable and also so similar to the Sun, and also because back in 2012 we've discovered several planets here, with originally 4 different planets assumed to be in orbit of this star system, Tau Ceti has been actually growing in popularity and has now become one of the most interesting stars in the vicinity, with some of the recent papers suggesting that this particular star system contains 8 different planets, kind of similar to solar system in that sense. And interestingly, at least one of these suggested planets seems to be in the habitable zone of Tau Ceti. And so it's really interesting to kind of explore this system once again, just to find out what we've learned about it in the last few years. Now, first of all, these original 4 planets discovered back in December of 2012 were actually discovered by looking at the slight wobbles of the star itself. They weren't discovered by looking at the shadows like we usually do, and so in this case by investigating slight changes in the velocity of the star. With the velocity changes of about 11 meters per second, the scientists were able to observe the original 4.
That wobble makes me think of the barycenter of a solar system. I've been really interested in that, how it turns out the Earth is not orbiting the Sun. What? Yeah, the Earth is not orbiting the Sun. That's the way I see it. We're orbiting the barycenter, the center of mass of the solar system, which is often inside the Sun, that center point, but not always. It's not that point. It varies and it goes outside of the Sun's surface at times. And so this wobble of a sun is how they start to calculate how many planets and sizes of the planets and stuff like that. I don't really know beyond there how they measure the wobble to figure out the masses. I don't understand the math there, but that's kind of the main idea.
4 planets, with all 4 planets being what you would call a super Earth or a mini Neptune. A lot more massive than planet Earth, but not as massive as, for example, Saturn and Jupiter. But as the scientists kept studying the data coming from this particular star, additional hints of other planets started to appear as well, including what seems to be a Jupiter-like planet at a slightly farther away distance of about 3 to maybe 20 astronomical units, and also several other objects that were definitely disrupting the motion of the star, suggesting more undiscovered objects. Now in 2017, 4 of these planets were officially confirmed, so now we're pretty certain there's at least 4 planets here, but the other 4 were only recently identified, and this was actually using a completely new mathematical algorithm known as dynamite for short, the study about which you can find in the description below. And what this particular algorithm allows us to do now is to use statistical analysis from other discoveries to try to predict the existence of other potential planets in a typical star system by knowing which planets already exist and how they would most likely interact with nearby planets.
Yeah.
All of this, of course, is based on the thousands of other objects we've discovered so far, and all of the other planetary interactions we've collected over the past few decades. And so using the dynamite algorithm, the scientists behind the paper in the description were able to find out the most likely locations of 4 other objects that are most likely present here. And one of these objects seems to be right in the middle of the habitable zone at a distance of about 0.7 astronomical units away from the center of the star. So basically somewhere right here. And although we obviously know nothing about the planet or what it's made out of, and obviously we don't even know if it's a super Earth, if it's a rocky planet, or if it's some sort of a strange mini Neptune-like object with a lot of hydrogen and helium on the surface, the presence of this planet in the habitable zone is still quite exciting. Just the idea that there could be a planet in the habitable zone around one of the most exciting stars in the vicinity is definitely a good enough reason to continuously investigate the star system to actually discover if this planet is truly there and what it might actually consist of. Now, based on all of the radial velocity observations and all of the other analysis, this particular planet is still going to be more massive than planet Earth, with all of the other planets also being at least 2 to 3 masses of Earth as well, possibly even more. It's a lot more likely that these are really massive planets, potentially even small gas giants, that don't really resemble Earth at all. They might be actually somewhat similar to Neptune and Uranus. And all of this is simply based on the idea that the star system here has very low metallicity. It doesn't really have as much silicon, as much iron. it doesn't have as many materials to make these terrestrial planets like what we have here in the solar system. But because we're still learning about how star systems are created and how planets form, all of this could be completely wrong. We could end up finding some really exciting planets here. Which is why, of course, it's kind of important to investigate the system when the new telescopes become available. However, one interesting difference about Tau Ceti compared to the solar system is that it also seems to possess about 10 times more dust, and obviously more asteroids and possibly more comets, than the solar system. This also implies that various impact events would be a lot more common on these planets. Now, this might not mean anything, but it also could mean everything.
Yeah, get different kind of homeowners insurance if you have that kind of thing wrecking into your planet.
It could mean that life might not actually have a chance to establish itself here. And at the same time, kind of similar to the asteroid belt around the solar system, the Tau Ceti system also seems to have a really large debris disk as well. And although seeing these disks is actually kind of common around other star systems, because Tau Ceti is over 5.8 billion years old, it sort of makes this a very interesting object to investigate because not a lot of old star systems, or at least none of the ones we've seen so far, seem to have these debris disks. Usually this is something that's common around young star systems, not really old systems. And so far, it looks like we found 7 either super-Earths or mini-Neptune-like objects, with at least one of them right in the middle of the habitable zone where we expect to have liquid water, but also a really large gas giant on the outskirts, somewhere near the so-called debris disk. In that sense, it's actually somewhat similar to the solar system as well, where we have Jupiter, more or less right after the asteroid belt as well. And naturally, because of all of these similarities to the solar system, because of all of the planets we've discovered here, and because the star is actually kind of calm, very similar to the sun as well, doesn't really produce a lot of flares, doesn't really do a lot of activity like some of the other nearby stars, and also because this star system is slowly approaching the solar system and is going to be doing this for the next 40,000 years, this is obviously one of the most exciting star systems we have near us, both for the reasons of potential exploration, for the reasons of potential life here, and also because by studying these solar analogs, we might actually understand a lot more about how various star systems form, and obviously start looking for signs of potential life around these planets as well. If life can exist anywhere, it's probably going to exist here. And if life doesn't exist here, well, in that case, it's probably something to do with that other video I made recently that does speculate that life on Earth might have been just really lucky. You can check it out somewhere above my head. But anyway, until we actually confirm the existence of these planets with some of the future observations, and until we actually know what they're made out of, and what sort of composition they have, there's really nothing else we can do for now. These predictions are still very preliminary, but having another star system with 8 planets is actually kind of exciting. Either way, it's very likely we're going to be returning to Tau Ceti once a new study comes out, either proving or disproving these findings, and also we're probably going to be talking about this once we actually get more observations from other telescopes, like the James Webb Telescope that's going to become operational relatively soon. Until then, well, that's pretty much it. Subscribe if you still haven't, share this with someone who loves learning about space and sciences, maybe come back tomorrow to learn something else. Also, maybe support this channel on Patreon or by buying the Wonderful Person t-shirt you can find in the description below. Either way, I'll see you tomorrow, space out, and as always, bye bye.
Perfect pause there. Tau Ceti. That stuff is really interesting. Wow. Basically a Goldilocks planet, and I mean, maybe there's a lot to figure out still. 12 light years. How long would that take us in a spaceship? 12 light years. I mean, roughly. I mean, is that like 1,000 human Earth years, or I don't know, or is it more like 100,000? I have no idea. I don't know. I kind of feel like if it's like 1,000, or I don't think it is. It's got to be a lot more than that. I don't know. Well, actually, no matter what, can't we just build an amazing rock ship? All the countries come together on a project, build a ship, inhabit it with a whole bunch of people with varied blood types and DNA and everything, so that they can have, offspring, and they can have offspring, and have a whole plan, and sustainable food, fuel, blah blah blah, everything you need to do it, and just launch them off into deep space. Easy for me to say, right? Well, I don't know. I just kind of get ramped up by these topics. I think they're, um, I don't know. This is the amazing stuff for us to be thinking about as a species. Pretty outstanding. I'm gonna have to reflect a lot more on all these facts. I hope you guys like this kind of video. As always, thank you for watching, supporting, commenting, all that kind of thing. And until next time, peace.